Okay, so if you're in the AI world at all, you've definitely heard the buzzword RAG, Retrieval-Augmented Generation. But here's the thing, it's not just some clever hack anymore. It's grown into this whole architectural discipline. And that's what we're going to do today. We're going to follow that journey, from a simple idea to a powerhouse reasoning system for AI.
All right, let's kick things off with a problem that I bet has frustrated every single one of us. You go to a super smart AI chatbot, you ask it about something that happened, just last week, and nothing. It just gives you this digital blank stare. It has absolutely no clue what you're on about. So what's going on there? Why does that happen?
Well, the root of the problem is actually pretty simple. Every single large language model, or LLM, has a knowledge cutoff date. Think of it like this. If a model was trained on data that stopped in 2021, it literally can't tell you who won the US Open in 2024. For that AI, the world just ends in 2021. It's not trying to be difficult, it just plain doesn't have the info. So the big question is, how do we fix that?
And that brings us to the most elegant solution out there right now, a technique called Retrieval-Augmented Generation. You've heard it, RAG. It is just a brilliant way to give these incredibly powerful models a direct line to fresh, brand new information, all without having to go through the massive, massive expense and time of retraining them from the ground up.
Honestly, the best way to wrap your head around RAG is this killer analogy. It's like giving an AI an open book exam, right? Instead of trying to force the AI to memorize literally everything, which is like a nightmare closed book test, RAG lets it look up the answers from a trusted source, like a textbook or the internet, right at the moment it needs the information. It's that simple. Okay, so in its most basic form, what people call naive RAG, it's a simple three-step dance. First, you ask a question. The system then retrieves relevant info. Step 2, it augments your original question by basically stapling that new info onto it. And finally, step 3, it just hands that whole new expanded prompt over to the LLM to generate the answer. See, it's a really straightforward pipeline. Find it, add it, answer it.
So you might be wondering, what's the magic behind that retrieve step? Well, it's this awesome technology called vector embeddings. The easiest way to think about it is like a universal translator for meaning. It takes any piece of text, a word, a sentence, whatever, and turns it into a set of numbers, like coordinates on a giant map. And here's the cool part. Things with similar meanings get plotted really close to each other on this map. This lets the system search for ideas and concepts, not just exact keywords. This is semantic search, and it's basically the engine that makes RAG go.
Okay, but here's where the plot thickens. That simple, three-step, naive RAG we just talked about, but when you see in every single Hello World tutorial, well, when it comes face-to-face with real-world problems, it often just breaks completely. There is this huge, widening gulf between a neat little demo and a system that you can actually rely on day in and day out.
And believe me, that gap is enormous. A tutorial, it's using perfectly clean data, simple one-shot questions. A real production system, on the other hand, has to deal with messy, complex documents, confusing user questions, and the need for rock-solid accuracy. That simple, one-pass search, it's just not going to fly.
So where are the failure points? Well, for one, that semantic search we love, it can totally miss specific keywords or important jargon. Then there's the noise problem. Sometimes it brings back a ton of irrelevant stuff that just confuses the LLM and makes the final answer even worse. And maybe the biggest one, a really good answer often needs to piece together information from multiple different places, not just one single document.
Okay, so how do the pros bridge this gulf? How do they build RAG systems that actually work in the wild? Well, they have a whole toolkit of production-grade techniques, each designed to solve one of these specific problems. So let's open up that toolkit and see how they build something way more robust.
All right, let's tackle problem number 1. Your vector search is amazing at understanding the vibe of a question, the general meaning. But it can totally whiff on a specific product ID, a crucial legal term, or some niche jargon. And if that one little term is the key to the whole question, your entire answer could be dead wrong.
The solution is something called hybrid search. And it's exactly what it sounds like. It combines the best of both worlds. It uses that dense, vector-based search for the semantic meaning, the vibe. But at the very same time, it uses a good old-fashioned, sparse, keyword-based search to nail those exact must-have terms. This two-pronged attack is pretty much the default now for any serious production-level RAG system.
Okay, on to the next headache. What happens when your first search pulls back a giant pile of documents, but, a lot of them are only kind of sort of relevant? If you just dump all that noise on the LLM, you're not just burning money on processing useless tokens, you're actually confusing the model and probably getting a worse answer. The fix for this is a really smart second step called re-ranking. Here's the strategy. First, you cast a really wide net. You retrieve a big batch of documents, maybe 50 of them. But then, and this is the key, a smaller, super specialized model comes in and acts like a judge. It looks at every single one of those 50 documents and gives it a specific score based on how relevant it is to your question. After that, you only pass the top few, the absolute best of the best, to the main LLM. It's a quality control filter that makes a huge difference, saving money and boosting accuracy like crazy.
So let's do a quick recap of our production toolkit. To catch those specific keywords we can't afford to miss, we use hybrid search. To get rid of all that irrelevant noise, we bring in a re-ranker. And for those really tricky, multi-part questions, we can even use something called query transformation to break the question down into smaller, bite-sized pieces before we even search. These are the tools that take RAG from a cool demo to a reliable system.
But what if the problem is so gnarly that even this souped-up pipeline isn't enough? For those kinds of challenges, we have to go beyond a fixed pipeline and step into the next frontier. And that is Agentic RAG. This is the point where the AI stops being a simple instruction follower and starts actually reasoning its way through a problem.
The big shift in thinking here is moving from that static assembly line process, retrieve, augment, generate, done, to a dynamic, intelligent loop. A loop where the system can actually think, act, check its work, and adapt on the fly. And what makes this all possible is the concept of an AI agent. Now, an agent is way more than just a chatbot. It's a system that's built to achieve a specific goal. It can reason, it can create a plan, and, this is crucial, it can use tools like our souped-up RAG system to get the job done. It's not just an answer machine, it's an active problem solver. A lot of times, this process follows a framework called REACT, which is short for reason and act. Basically, the agent gets into this continuous cycle. First, it thinks about the problem and figures out a plan. Then it acts on that plan, maybe by running a search. After that, it observes the results and asks itself, did that work? Am I done? If the answer is no, it refines its thinking and takes another action. It just keeps repeating that think, act, observe loop until the job is done.
And this right here is the ultimate evolution of RAG. With an agentic system, the LLM is no longer just the text generator tacked on at the end of the pipeline. It gets a promotion. It becomes the brain of the entire operation. It's the central controller calling the shots, deciding what to search for, what tools to pull out of the toolkit, and ultimately deciding when the problem is actually solved.
So let's just trace that entire journey one last time. We started with naive RAG, a really simple concept, but one that often fails in the real world. From there, we leveled up to production RAG, where we added a whole toolkit, hybrid search, re-ranking, to make the system tough and reliable. And finally, we took the huge leap to agentic RAG, where that pipeline transforms into a powerful tool wielded by a reasoning AI agent.
And all of this leaves us with one last big thought to chew on. If classic RAG is all about giving an AI access to knowledge, could Agentic RAG be the first step toward giving it something more? We're talking about a system that doesn't just have facts, but knows how to find them, how to judge them, and how to use them to solve really hard problems. You have to wonder, is this how we get from just raw knowledge to something that starts to look a lot like wisdom?